Hi, welcome to my second video, and let's have a look at how Perceptron works as a simple computing element. Previously, we have already learned about the variables that is included inside a perceptron. We have learned that this is called a neuron, and we have a weight value that connects between the input neuron to the output neuron. So the interconnected links are called weights. Alright, so how does the output is calculated? Imagine you have an input and the input is then calculated at the output neuron. So the calculation is as follows. So first of all, we need to calculate the sum of the product of the input times weight. Again, we need to calculate the sum of the product of input times weight. Then, we need to add with the bias times the threshold value. What is the threshold value? The threshold value of a perceptron acts like a weight. Only that the threshold value of a perceptron is a constant, while the weights of the neural network of the perceptron will later be adjusted accordingly when we train our neural network. And then the calculated value of this dot product plus the bias times weight will be used as a parameter for the activation function that we choose. In this case, we will use a step activation function. So these are the equation reduced to a simpler equation. Because in our case here, the bias is either positive or a negative value. Sorry, the bias is either positive or negative value is multiplied with the threshold value. So the threshold value immediately becomes a negative threshold. All right, so let's look at what are the steps that is involved in a perceptron. Step number one, we will initialize all the parameters of the perceptron. So the parameters is the weights, the threshold, and the alpha value. What is alpha value? Alpha value is the learning rate of the neural network. The learning rate usually is set at a very low value, for example, 0.1. We will discuss this later why do alpha value has a very low value. In our example, most of our weight and threshold is set randomly in between negative 0.5 to 0.5. Step number 2 is activation. We will activate the perceptron by applying the input x1, x2, and so on to produce the desired output y1. We have already looked into the calculation previously. Don't worry, as we do the exercise later, we will try to understand how the activation of the perceptron works better. Step number 3 is weight training. During weight training, the weight is adjusted in order for the neural network to produce a correct output. In order to do that, we need to calculate the error first. So the error is calculated as desired output minus the actual output. What is a desired output? So the desired output is the label of the combination of data. And the actual output is the output produced by the perceptron. When we have already calculated the error, we can now calculate the weight change, which is identified as the delta weight. The delta weight is denoted with the triangle symbol. This equation reads as the delta weight is equivalent to the alpha times input times error. When we have already calculated the delta weight, now we can update the weight by adding the current weight to the calculated weight change. So the equation is the current weight, the newly created weight is equivalent to the current weight plus delta weight. Again, the new weight is equivalent to the current weight plus delta weight. So P plus 1 is the new weight and P is the current weight. Step number 4 is to simply repeat step number 2 with the newly updated weight P plus 1. If the error is 0, the weight should stay the same value. And the iteration is ended when the perceptron reaches 0 error for all possible input and output pairs. Let's look at this exercise. Can perceptron learn the AND or AND exclusive OR function? So these are examples of a perceptron with two input neurons, which is x1 and x2. Because our perceptron will only have two input neurons and the input is a binary value, we can only have four combination of input, which is 0, 0, 0, 1, 1, 0, and 1, 1. We won't have any other combination as it is already a complete combination of binary value that consists of two neurons. Let's see how the perceptron can produce the output using an AND function. Now, our first exercise, we will learn how the perceptron will be able to produce the correct labels. So this is the desired output, the labels, Y desired, and this is the input. All right, so let's look at this table. From this table, okay, we have several row of calculation. So each of the row is actually the sample of input that should produce the output. So these are the input neuron that produce this output. But this is only the label. The correct output that is produced by the network is this one, which is the actual output. In order for us to understand this table, let's look at the parameter. All right, so this we have down here is the threshold value, which is 0.2, and the learning rate alpha 0.1. And then our initial weight are set at 0.3 for weight 1 and negative 0.1 for weight 2. Our perceptron architecture will look like this. x1, x2, weight 1 and weight 2, which produce y as the actual output. So let's see how the actual output is produced. Again, in this example, we will use the binary step activation function. So the calculation of the summation of the input value is the input 0 times weight, which produces 0. And then x2 times weight 2, which also produce the value 0. Minus the threshold value 0.2, our summation value is negative 0.2. This value will then be a parameter for the binary step function, which shows that the x-axis of the binary step will produce a 0 value. If we look back at our activation function here, any negative value will produce the output 0. So that's why our actual output is 0. Again, if we look into the example here, it says that if the error is 0, the weight should stay the same value. Why does this happen? Because the weight change is dependent on the error. Any value that is multiplied with 0 will produce a weight change of 0. So when the weight change is 0, when we calculate the newly created weight by adding up the current weight with the weight change, the weight will stay the same. That's the reason why the final weight for the first sample or the first iteration is the same as the initial weight. Alright, so for the second iteration, things work well. There's no error produced. You can do the calculation yourself in order to understand how the actual output is produced and how the error is calculated. Please do this on your own. Let's look at the third iteration. Now, the third iteration should produce an actual output of 1, and this will produce an error. So let's do the simple calculation first. So the output is created by multiplying the input 1 times with 1, 0.3, which is 0.3, plus 0 times negative 0.1, which equal to 0.3, minus the threshold value 0.2 here, which eventually have us having the value of 0.1 as the parameter input for the binary step activation function. Because 0.1 is a positive value, the binary step function will activate the actual output of 1. However, our desired output is 0. Now, we should have an error. So the error is calculated as desired minus actual, like this one. Desired minus actual. That's the reason we get a negative 1 error here. After we have already calculated the error, the final weight is calculated as the current weight plus the weight change. So the weight change is calculated as alpha, which is 0.1, times the input, which is 1, times error, which is -1. So we'll get the value of negative 0.1. So that value is then added up to the initial weight. We'll get the final weight value of 0.2. Now let's look at final weight 2. If we can see here, final weight 2 and initial weight 2 is of the same value. The weight doesn't change at all. Why does this happen? Even though the error is -1. Let's look at how the weight change is calculated. Again, the weight change is calculated as alpha times input times error. Because our input at the third iteration is 0, immediately the weight change becomes 0. Thus, when we add up the initial weight plus the delta weight, which is the weight change value, we will get the same final weight. I hope that my explanation clears up how perceptron learning works. Please do this exercise on your own and try to calculate or try to understand how the table is calculated until we get 0 error for all of the iteration. When we get 0 error for all 4 iterations, it shows that our perceptron have already managed to learn the combination of AND operation. Thank you very much.